everybody. My name is Renato Morales. I am from Guatemala, San Carlos University, and I will present my work with Holcosus undulatus, that is called the new lineage of Holcosus undulatus in Guatemala. In 2007, Marshall proposed the physiographic province for nuclear Central America. In this figure, we can see the Mayan highlands, the Yucatan platform, the Motagua fault zone, the volcanic front, and Guatemalan coastal plains. The topography and physiography province are important because the population of amphibians and reptiles have responded and generating a big diversity of species in this part of the tropics. Within this diversity of reptiles, I worked with Holcosus undulatus. Holcosus undulatus was described by Whitman in 1834. He described two forms, alpha and beta. After the description, 11 subspecies had been described from northern Mexico to Costa Rica. There are a few efforts on the systematics of the complex. I present two of the most important to me, Smith and Laufe 1942 and NADH 1971. Smith and Laufe make the first systematic of the group for Mexico and Guatemala. They made migration reconstructions and with morphological data, and they concluded that the subspecies exist for this group, but they are not different species. NADH says the opposite. He worked with all the distribution with morphological data, and he concluded that the subspecies doesn't exist. All the variation are clines, which are gradual change of morphology through the distribution. And the only molecular background is from Meza-Lázaro and Nieto-Montes de Oca in 2015. They used mitochondrial DNA and nuclear data, and they make phylogenetic analysis and shows that with the mitochondrial data, the subspecies have a strong genetic structure, but with the nuclear, there is not an evident pattern. They conclude that some subspecies have to recognize it as a species, and two stay in subspecies level, the extremiades. After this work, there were only 3 species for Guatemala: Harwegi, Tomasi, and Parvus in the coasts. Nevertheless, there are information gaps for some areas in Guatemala that were left out of the analysis, and they do not present a nomenclature act, and for this reason, knowing the information gap and the complex of the physiography, my question was, how many genetic lineages do we have in Guatemala? My objectives was determine the genetic lineage, the divergent times, and the important barriers for the genetic lineage of Holcosus undulatus in Guatemala. My methods: I collected samples from Izabal, Petén, Zacapa, and Jutiapa to fill the information gap in Guatemala and download 49 sequences for Mexico to Honduras. I used the same mitochondrial marker of Meza-Lázaro in 2015 and using Sanger sequence method. I did the alignment in Mega and the analysis on Cypress portal. My analysis: I use Bayesian inference and maximum likelihood phylogenetic trees. For divergence time, I did a relaxed molecular clock using BEAST, and for the physiographic correspondence, I plot my phylogenetic tree with physiographic map. My results: the Bayesian tree has the best node support for the close relationships. Important parts of the tree are recognized the groups previously described: Holcosus parvus, Holcosus undulatus thomasi, Holcosus undulatus harwegi, Holcosus undulatus gaige, and Holcosus undulatus pulcher. Geiger is the first intersect group because my sample of Peten should be Harwigi, but instead they are part of Geiger clade. One sample, he belongs morphologically to Harwigi, but genetically he belongs to Geiger. It's possible that could be part of hybridization process, and the others two samples that I have of the 10, they belongs to Geiger in the morphological and genetical part. They represent a new record of the country because this clade was endemic to Mexico. I recognize new lineage. Valle de Motagua and Sanarate is one of the new. Pacífico de Chiapas is a new lineage for Mexico. Comayagua for Honduras, and Izabal for Guatemala. The maximum likelihood tree shows the same topology and the same groups. The only difference is the relationship of the Comayagua clade or the Comayagua sequence in the trees. The molecular clock shows that the history of the group began in the Middle Miocene, 11 million years ago. 11 million years ago, the physiography of Guatemala was like today, but the altitude of the barrier was lower. And why is this? Because the Mayan highlands were originated to 70 to 60 million years ago. Cuchumatanes, the Motagua fault zone were 35 million years ago. Chortís volcanic front have two origins, Tertiary and Quaternary epoch, and Cuchumatanes range is from Cretaceous 145 to 66 million years ago. For this, I assume that the history of the group is a dispersal history. In the Middle Miocene epoch, we have the diversification of Comayagua clade, Harwigi clade, Geiger clade, and the parental population of the other clades. In this epoch, most of the Guatemalan plains were savannas and came of the high temperature. The lizards have a strong thermic niche, so I think the temperature was important. Was important for the diversification process in this Middle Miocene. The last Miocene was important because it's a vicariance process for nuclear Central America, and this is because the Isthmus of Tehuantepec and Nicaragua get flooded. Like here, and the Atlantic and Pacific Oceans were in contact again, so the process were just for the nuclear populations, and in the final the temperature get cooler. In the Pliocene epoch, we can see an interesting process of diversification. 6 lineages diverged in 4 million years ago. In the final of the early Pliocene, the temperature got high again, and the habitats were more diverse. The fossil records show that in the Pliocene in Honduras and Guatemala existed rainforest, dry forest, and pine oak forest. So this diversity of habitats and high temperatures could be beneficial for the diversification of these groups. To see if the population respond to physiography, I plot the Bayesian tree, and we can see a structure of the populations for the physiography. In this map, we can see more graphically the physiography and the physiography province of the structure in the populations. We can see the Mayan highlands, we can see the Motagua fault, and the volcano front. As conclusions, Guatemala has 6 Holcosus lineages, at least with this mitochondrial marker, 4 of them with taxonomy names: Parvus for Pacific coast of Guatemala, Tomasi for Huehuetenango, Harwigi and Geiger for Petén and Alta Verapaz, and 2 new lineages without taxonomic names: Motagua Valley and south of Izabal. The clade of Geiger represents a new record for the country. Previously, this clade was endemic of Mexico. The clade of Parvus need more samples to try to resolve the polytomy in the clade. The same with Motagua Valley clade. They have a polytomy inside of the clay. The date shown by the molecular clock matches with important climatic events like temperature fluctuations. The temperature and the habitat availability were important process for the diversification in the Pliocene epoch. The physiography is an important driver of diversification for this group. In Guatemala, the most important are Mortagua Fault, Cuchumatanes Range to Sierra Santa Cruz, Volcanic Front, and Maya Highlands. I want to thank Alejandra Morales and Adrian Nieto, they were my advisors, Sergio Perez for the help on the molecular lab, and all the forest guards of the protected areas. If you have any comments or questions, I will be happy to hear it. Thank you very much.